So tonight we're going to learn how to use a relay to run large inverters for a lithium iron phosphate based raw cell solar power system. So what that means is that instead of being limited to the current rating of your BMS, which is typically 100 or 150, we're going to use the BMS to trigger a 500 amp relay so we can run continuous 500 amp loads all day long. And these are very simple to use, and any BMS on the market can easily switch these on or off. So let's talk about how this works. This BMS connects to the main negative terminal of the battery. It has a balance lead, and then it has a P minus for the loads. This creates 12 volts for the loads if everything is happy and healthy with your battery cells. So what we're going to do is take this 12 volts and power a relay with these two small terminals. And when you give these terminals 12 volts, a coil will be energized and these two terminals will be shorted out, or there'll be a closed circuit. And so what we want to attach right here is the inverter negative cable. So all the relay does is act as a very, very large switch. And what's really cool about using this large relay is that we can push our lithium iron phosphate cells to the limit. Typically, a 100 amp hour cell can handle a 3C discharge rate. That's 300 amps. If your BMS can only push 100 amps, but those cells can push 300 amps, you have a huge bottleneck on your system. And if you want to power very large loads on an inverter with a smaller battery, or you can't find a BMS with a high enough current rating, you can easily use a relay to run that load. When this relay switches on, you will hear a very distinct click, and I want to show it to you guys. So let's connect it to a power supply. So we have a negative right there, and then we have a positive right here. Do you hear that? But keep in mind that this coil can be energized and it can shock the heck out of you. I've been shocked many times. This is a big relay, so this will give you a pretty good shock. Now let's give an example of how you would wire this relay into a solar power system. First, we have two terminals and they need 12 volts. So this one's going to go to the main positive terminal of your battery. And then this one will go to the BMS output, or the P negative. Whatever your BMS connects to loads for low voltage disconnect, you want to connect this wire to that. And then these two large terminals, these large wires, will go between your inverter and your battery. This could be the inverter negative cable. It could be the inverter positive cable. It does not matter. Something else that doesn't matter is the polarity of these two terminals. So this could be positive and this could be negative, like it is right now with the color coding, or this could be positive and this could be negative. This is a magnet. And so whether you have the polarity switched or not does not matter. So the small terminals, one goes to main positive and then one goes to BMS output, and that's all you need to know. And to show this in action, we have 14.3 volts with the power supply. We're going to put the negative on the negative and the positive on the positive, and it actually turns on. But let's reverse the polarity. So we put the positive on the previous negative and the negative on the positive, and it still works. Something else that doesn't matter is whether this is a positive or a negative inverter cable. And that's because it is electrically isolated or non-conductive or insulated from the small terminals. So check this out. Let's put a lead on the small terminal and then on one of the big terminals. And look, there is no amperage draw on the power supply, so there is no short circuit. And now let's do it to the other terminal, and guess what? No draw. But if I put on the tiny terminal, there is a power draw. And look at that, we have 14.3 volts and 0.6 amps. So we can use that watt consumption to figure out how much power this consumes continuously just to stay on. And some people might be worried, why am I going to run a relay that uses power all day long to run my large loads with the inverter? If you can have your inverter in standby 24 hours a day, a tiny relay is not going to consume much. Typically it's around 3 to 4 watts max. A 200 amp is around 1 watt continuously. So over the course of a day, that is not much power at all. But if you are concerned about how much power a relay draws throughout the day, you want to put a switch on one of the power lines for the small terminals, so you can turn your inverter on or off manually whenever you need it. But on some fancy inverters, there's actually a relay input for turning on and off the inverter. But if you know about that, you probably won't be watching this video, but you can use a cheap BMS to trigger that. So that's always an option. You can program that yourself. Just a safety reminder, the dangerous terminals are these two small ones right here. If you energize this coil, take off the power, and you touch it, and that coil is still charged, it will shock you. So So now we're going to test if this system actually works. We are going to run a large inverter through a very small, cheap BMS. This is a separate port BMS, so the P negative wire where the load's attached to is attached to the tiny terminal of the relay. And then the other tiny terminal of the relay connects to the main positive. And this relay will control the inverter through the negative wire of the inverter. And then we have a positive wire to the inverter. So if this BMS senses the voltages of the cells as being happy and healthy, it will keep power on for this wire and it will keep the relay on. If this BMS detects that one of the cells is too low, then it will turn off the relay and turn off our inverter. This will ensure that our cells do not get over discharged, which for lithium iron phosphate can be devastating. You will have a reduced capacity instantly. So we need to ensure that our low voltage disconnect system works, so we're going to test it out. And right now the BMS is connected and the relay is in an on state. So that means that the inverter can now be switched on, so let's do that. And we're pulling 142 amps continuously. So we're going to run this battery until it dies. How cool was that, guys? The BMS shut off the relay, which shut off the inverter, and now the cells are protected. And because this is a separate port BMS, we're going to add a charger to the charge lead, and look, it just turned back on again. So now the inverter has power once the battery starts charging up again. And that's pretty much it, guys. A very simple system here. And I think that's pretty much everything I can say about these relays. These are very simple little contraptions, and I hope you guys actually use these in your system because they work really well. So yeah, let me know in the comment section below if anything did not make sense, and I will talk to you soon. Goodbye.